huge real-world application for sure. Small little paragraph, yet there's a lot going on that we're about to do. Okay, so here's your premise. Your goal is to try to read all of this and come up with 2 words that basically tell you what you're going to do for the problem. So we have 40 feet of fence to enclose a rectangular garden along the side of a barn. Okay? What is the maximum area that you can enclose? It does feel a lot like pre-cal optimization, but it's much more efficient, much easier to work with, and you can actually do it without a calculator. Okay, here we go. In 2 words, what are we trying to do in this problem? Maximize area. So here we go. Maximize area. It's going to feel a lot like related rates. Okay, and the steps with this at least are very consistent, just like they are with related rates. The premise is you have to determine what pieces you're given and to find ultimately what it is that you're looking for. So the area of what? Give me an equation that gives me the area. Go ahead, just say it.
A equals s squared.
Not s squared on this because it's a rectangle. So length times width, or base times height. Let's go with length times width. Okay? Now here we go. Just like with related rates, my best suggestion to you is to draw a picture, okay? And we have a rectangular garden coming off the side of this barn, okay? We'll label this as L and L because it's a rectangle, and then we could say that this is W. So my primary equation, for the most part, that we're trying to work with is the area formula. I will need to use a secondary equation, though, in order to produce this equation. Okay, here we go. I'm going to use the fact that they gave me 2L plus W is equal to 40. Notice that I did not put 2W because I'm using the side of the barn. Okay? So now I'm going to solve for W. And now I have W in terms of L. That means I can, with substitution, which you will do everywhere in optimization, you're going to substitute this value in for W. So your equation becomes not only A, but A of L. Think of like f of x. Okay? L is my input that will give me an area. Okay? So the independent variable is L, the dependent is area. And it'll be L times 40 minus 2L. There's my equation. And my goal is to maximize this. Yes?
And do you want us to distribute the L? Or
so here's what I'll say. The use of calculator is definitely important for today, for sure. But knowing how to do this by hand as well is a big part of this. The questions that you will have on the test, if it's something that is without a calculator, there will be clean numbers. Okay, they're not going to be some weird hard decimal numbers, of course. But for the most part, let's go ahead and simplify this out so we can put it into our calculator. So 40L minus 2L squared is equal to A of L. Okay, please be handy with the calculator because you're about to follow me, and there's a lot that's about to happen. Okay, so if I were to do this by hand, and we'll verify with the calculator, I can say A prime of L is equal to 40 minus 4L. I'm looking for this equation in your work, and I'm also looking to see, did you set it equal to 0? Did you set that derivative equal to 0%? Okay? So the practice that we've been doing lately, you probably would end up writing something that looks like this, like going from here up here, setting our derivative equal to 0 because you're looking for critical points. And the critical point that you would find here would be 10. You tell me, how do I label this number line? What are we going to label it as? Yeah, A prime of L, aka f prime of x, the first derivative. if we tested these intervals the way we've been doing this unit, and we plugged in something for L on this first one, let's say 9, would I have a positive or a negative? Positive. Let's say I plugged in 11. What would I have? Negative. So what I just realized is a possible max. We know it's relative. Could it be the absolute? You tell me real quick. Could it be the absolute? It can. If and only if 10 is the only critical point. You with me? Are there any other critical points that you see that exist? No. So you don't have to use candidates test. Okay? The first go-to that I want you to do is first derivative test. And if there's only one critical point, that's all you have to mention. And then you will be correct. Okay? So here we go. For first derivative test, we're going to say that the maximum area equals something when L is equal to 10. And in this case, it's 10 feet. You're going to say because L equals 10 is the only critical point where A prime of L changes from positive to negative. You with me? Now all we have to do is plug it into the equation that actually gives area. Well, if L is 10, the place that we're going to plug this in is right here. Or any of these that are A of L, not A prime. So what would I get? 200. 200 square feet. So this is definitely one that you're capable of doing without the aid of a calculator. Okay? So let's talk through it. We established what equation we were trying to work with. We got it in terms of one variable. We knew that we were going to maximize it, so we took the derivative, found the only critical point that existed, and we verified that it was positive to negative. And if you do it this way, you must mention that it's the only critical point that exists, and that it does change from positive to negative. Okay, so this would be the absolute max. Questions before I show you with the calculator? Okay, so here we go. What we're going to do is we're going to together go through the calculator parts, and if you have any questions, please ask me. Let's go ahead and begin that right now. Alright, so let me capture. Let me go ahead and log in just real quick. Okay, so here we go. From a new document, no to unsaved changes, I'm going to grab a calculator page. And what I'm going to do first is store my original position function that I established. And my position function that I established was 40L minus 2L squared. And yes, you can use, if you want, you can use X. Just make sure that you keep track of what variables stand for what. Okay? So this is going to give me Control Store. So press the blue button, press bar. Gives you that nice arrow. And you're going to store this as the area with L as the input. Yes, you could do this as f of x as well if you wanted to. All right, here we go. Now, I'm going to show you, first of all, how you can find the derivative and find the zeros just like that, the critical points. Here we go. First of all, let's say I want to find the derivative of this. Press this key next to 9. This is the first derivative. I'm in respect to L, and I'm I'm going to find the derivative of my stored function called a of L. Okay? Now, if I set this equal to 0, menu 3, 1, set this equal to 0, comma L, I see that my critical point exists at 10. There's a faster way to do what we just did, and I'll show you that right now. From here, you can press menu 3, 1, and I'm going to solve when the derivative in respect to L of my saved function a of L, now watch very carefully right now, I'm going to kick out just one parentheses out and set it equal to 0. And you always have to tell the calculator what to solve for. So we'll put comma L. If I press Control Enter, it goes straight to that 10. And this 10, guys, that we just found is this 10 right here that we were finding by hand. Okay? This is when the derivative is equal to 0. Okay, so now what I'm going to do is I'm going to test to the left of 10 and I'm going to test to the right of 10. You need to learn this stuff, otherwise you may not finish the test because of time. Okay, here we go. So again, I'm going to test the signs of this interval, which I showed by hand right here and right here with the calculator. Here we go. So I'll go over here and press menu 4 for calculus, 2 for derivative at a point. What's my variable? L. What value can we put? 10. Not 10. 9. We're going to put 9. We're going to put something to the left of that critical point. So we're going to test 9. And we're going to do the first derivative. And here we go. This is the notation of whatever it is that I stored as my position function. So I'm going to put in right here a parentheses of L. And you can see A is bolded because it's stored. Control Enter is a good habit to get into. And what I care most about this number is the fact that it's what? Positive. Okay? Now look, let's test something to the right of 10. It could even be 10.01. You see that it's negative. So what we just did is that we verified with the calculator the signs that we got right here and right here, which told us there's a possible absolute max, because we know it's a relative because of first derivative test. You with me? Okay. So I know that this epiphany or whatever that we realized happened at 10. This maximum occurred at 10. So it's saying, what is the maximum area? So I can get 200 simply with the calculator by using the stored function that I have in there right now. Okay, so here we go. We're just going to do, what is a of 10? Boom, there it is. So you're using that stored function a lot of different places, and I'm wanting to show and help you with the calculator usage of all these problems as much as I can. Any questions? Okay, so there's that one.